Hello, and thank you for tuning in to watch this lecture. This was the lecture we were going to do at the store in March on DNA, nitric oxide, NADH, and hydrogen water, but circumstances have changed, so we're putting it up online so you'll be able to watch it. If at the end you have any questions, feel free to email me at gary@naturalcompounder.com, or you can call and leave a message and I'll get back to you at 781-893-3870, extension 111. So a biological pathway is a series of actions amongst molecules in a cell that leads to a certain product or a change in the cell. It can trigger the assembly of new molecules such as fats, proteins, or turn genes on and off, or spur a cell to move. These are very important because the functions performed in a pathway are the foundation of either health or illness. Cells constantly receive cues from things such as inhaled or absorbed chemicals, metabolism of nutrients, injury, infection, stress, or the presence or lack of food. To react and adjust to these cues, cells send and receive signals through biological pathways. The molecules that make up biological pathways interact with signals as well as with each other to carry out their designated tasks. These pathways can act over short or long distances. For example, some cells can signal to a nearby cell to repair localized damage, such as a scratch on a knee. Other cells produce substances such as hormones that travel through the blood to distant target cells. These biological pathways control a person's response to the world. For example, some pathways subtly affect how the body processes drugs, while others play a major role in how a fertilized egg develops into a baby. Other pathways maintain balance while a person is walking, control how and when the pupil in the eye opens or closes in response to light, and affects the skin's reaction to change in temperature. Biological pathways do not always work properly. When something goes wrong in a pathway, the result can be a disease such as cancer or diabetes. We are going to look at some pathways which have been well studied. When we come to understand their function, we'll also see the importance of addressing their dysfunction. Each of these pathways requires cofactors, specific nutrient support which can help the processes needed to be performed. SNPs, you'll hear this word a lot, single nucleotide polymorphisms, can change the way things function in a pathway. SNPs occur when a cell divides itself into two to make a new cell, but doesn't properly copy the DNA, leaving the new cell with an incomplete set of genetic instructions. This can change the way a gene functions. If a gene without a SNP, which is normal, holds instructions for an enzyme to be formed, the same gene with a SNP could then have a poor copy of instructions for making this enzyme. Instead of creating a well-functioning enzyme, it may alter the way the enzyme functions, which can affect the way the body processes, or how it works or doesn't work. More than half the population has SNPs that can reduce the activity of one or more enzymes by up to 70%. Several SNPs directly affect nutrient assimilation or absorption and response to supplementation. A targeted nutritional approach is the most effective way to address these deficiencies. So now we'll talk a little bit more about SNPs. Some SNPs account for differences of types of hair color, or if your hair is straight or curly. Others affect how we develop disease or respond to drugs. Most lead to no observable differences at all. Some SNPs impact the production of enzymes, which is the purpose of this discussion, because we can have an effect on that. When you have SNPs in the genes that make the enzymes, the function may be impaired. So this is a chart just to show how with different SNPs, it really isn't that simple that if you have one SNP that this is the supplement to take and that'll fix everything. As you can see, there's a lot that goes on, and there's a lot of different pathways that can have an effect on each other. If we look over here, we have NADH and NADPH. We'll be talking about that. If there's a problem here, that can affect the SIRT3 enzyme or the FOXO, which we'll talk about a little later. That has to do with how you use your antioxidants and your inflammation problems or not having inflammation. Also, there are different enzymes that can affect how the body uses NADH. So if there's a problem with IDH3, you may not have enough NADH being made, which then can affect inflammation. So we really have to look at the whole process, not just at a specific enzyme. So this is just one little part of a lot of the different pathways. It could fill up, if we made a chart, it could probably be 10 or 15 feet long to put the pathways that we know about. So you really have to look at the overall picture. If you're genetically predisposed to a disease or a condition, it means that your risk of contracting it is higher simply because of your genetic makeup. It does not, however, mean that you'll definitely come down with the illness. Typically, something else would have to come into play. For instance, someone with a genetic predisposition to fibromyalgia may not develop it until he or she is exposed to long-term stress, then suffers a physical or emotional trauma. A trigger or stressor turns on the issue. The most common triggers are high levels of stress, surgery, labor, a car crash, a fall, poor diet, smoking. Anything with a major physical or emotional impact on the body can have an effect on gene SNPs. Stress management techniques such as exercise, warm baths, a good night's sleep, and knowing your limitations can have significant impact on your well-being. So what do we need to do? We need to look at the genetic report and look for SNPs that may impact or in a certain area or a certain pathway that can be leading to a problem a person's having. Once we identify this, we support nutrient absorption, the digestive enzymes, basically the gut. That has to be working well. We look for cofactors where they're needed. We want people and we need people to start living a more anti-inflammatory lifestyle, avoid toxins, reduce inflammation by a healthier diet, and low-impact exercise. Other inflammation reducers could be omega-3 fatty acids, vitamin C, vitamin E, CoQ10, PQQ, grapeseed extract, L-carnitine, zinc, and glutathione. But we need to know, does the body need these supplements? It's not just take them to fix it. Everyone is different, and everyone's imbalance and needs is different. We want to eat a healthy diet, organic as much as possible, healthy proteins, healthy fats, low sugar, and eat very little processed foods. Hopefully you can eliminate it completely. We need to support the microbiome with probiotics, organic food with prebiotic fiber like inulin, beta-glucan, and pectin. And we need to make sure the elimination pathway is working and keep the bowel healthy with hydration, fiber, movement, and cleaning up any imbalances that are there. If you learn to understand the metabolic pathways, you'll understand how the body really works. So metabolism is really the sum total of all chemical activities in the cells in our body. So this is how you should be thinking about your body, how it's doing. Not one pathway or one gene, but it's the sum of how everything is working together. So there's different types of genetic testing out there. There's disease prediction. When women become pregnant or thinking of getting pregnant, there are different genetic tests that can be done to see if the offspring will be susceptible to some awful diseases. There's also genetic testing, which is the most popular now, for your ancestry, to see where your family comes from, if you're connected to other people. There's testing for how the body metabolizes drugs. This can be very helpful, especially on the anti-anxiety and the antidepressive drugs. If you have a genetic predisposition that a pathway isn't going to work well, then you don't want to take a drug that requires that pathway for it to be activated. So this can be helpful in choosing different pharmaceuticals. And what we do at Johnson's, and what this lecture is about, is studying the genetics that could affect your methylation pathway, which is on this chart, and the other different metabolic pathways, because that can give you some good information, and we have a lot of ways to assist the body if they're having problems with methylation or with the metabolic pathways. Looking at this chart, here's the MTHFR right here, and that's what a lot of docs are testing. And if you think of each of these rings and each of these lines as gears in a watch, an old-fashioned watch, if the MTHFR enzyme isn't working well, this gear is dirty. It isn't spinning well. And this cycle here feeds into this cycle, which then feeds into this cycle, the nitric oxide cycle. This cycle has to do with making your neurotransmitters, serotonin and dopamine. Going this way, we need methylated folic acid, the MTHFR enzyme, working well to feed into this cycle to combine with methylated B12 to help with methylation. So if there's any problem in any of these areas, it can affect any pathway and any function in this whole diagram. So it isn't just giving methylfolate. We have to look at how everything is being affected. So the basic premise of methyl-genetic nutrition is we're born with our genes. They're what we're born with and what we're going to die with. But lifestyle can trigger the SNPs to activate. So just because we have a SNP doesn't mean there's a problem there. A good example is a revolver. Our genes are a loaded revolver with the hammer pulled back and is pointed at our body. Our epigenetics is our diet, our lifestyle, our toxic exposure, our digestion and elimination. That's what pulls the trigger and causes the activation or the damage. So we can do things, even if the trigger's been pulled, to take our finger off the trigger, and we can clean up the metabolic mess, clean up those gears in the watch, and get that body back into a good metabolic balance. So all isn't lost if you have a SNP, and also if your lifestyle triggered it. With the proper work, a lot of times you can reverse the damage and the problems that are occurring. So what we do is we look at the DNA genetic variants, we support metabolic pathways that are needed, we clean up the metabolic mess that was generated, we don't treat the genes. The goal is to help the body and the mind function better, to help stop the buildup of free radicals and toxins. This will decrease oxidative stress, it'll increase antioxidant levels, which helps protect you, and it supports detoxification and helps rebuild cells and organs. So now we'll look at some gene SNPs, how they affect enzymes. We'll look at the SNPs, the enzyme function and pathways. There's some great testing available now to help see if there's issues in these pathways if you have the SNPs. There's the organic acid test, the O test. There's a methylation test. There's Nutrival, which has the organic acids, and it checks how your body is doing with a slew of nutrients and how they're being activated and metabolized. We're going to be looking, when we do the testing, at how different genes and pathway combinations interact, and we're going to help work to get the whole person in balance, not treat the SNPs. As new information is discovered, your report is updated automatically at no charge, because this is a real evolving science. Every day, week, and month, new information is coming out, and new information on different genes and SNPs and enzymes, how they interact. So the researchers that we work with offer that as new information comes up, they're going to update everyone's report whenever that happens at no charge. So instead of treating SNPs or symptoms, we're going to focus on finding a pathway that isn't working, or if there's a nutrient deficiency, or an excess of a molecule that's toxic or gumming up that gear or that pathway, or that's harmful to the body, and help the body eliminate it. We do this with supplementation, with diet and lifestyle changes. We help with detoxing and cleaning up the metabolic mess. That's really the first step in this. So you do a simple saliva test. That's how they collect the genetic material. To the lab, you're just a number. So they don't have any idea of your name or your address or your age. They just have a number assigned to the vial that has your saliva. There's an online symptomology survey that needs to be filled out. If you have any lab reports, you can get them to me and I can enter those in, and if need be, we can order some of the tests, the organic acid or hormone testing, whatever is needed. And we use all this data combined along with your history and how you're feeling to put together a customized protocol for you. To show you how this is evolving, this is Bob Miller. And he was the person who started this research group. And as they were getting more and more data in, more and more people doing the genetic analysis, he found a connection between a statistically significant number of people that had chronic Lyme and weren't getting better, and there were a whole bunch of SNPs that most of these people had. It was clinically significant. So he went to ILADS, the International Lyme Association, and he presented his findings. He didn't know what this connection meant at that time in 2016, and they won the International ILADS Award 2 years in a row for these discoveries. And by everyone putting their heads together, and all the researchers and the people at ILADS, they figured out why this combination of gene SNPs is preventing a lot of people with chronic Lyme from getting better. So I put this in here because this is just showing it's really an evolving science, and all these people who have even did their genetic analysis 5 years ago, their reports are getting updated as more information comes in. Now the testing is about 200,000 genes. And that's a lot of data. It's about 800 pages of reports, which is very hard to try to figure out and go through and remember all the connections. So the group that we work with, the programmers figured out a way to put it in this chart. And let's see if I can get my mouse over. It color codes different areas by how many SNPs or how many symptoms. So in each box, this first circle talks about the SNPs that can affect these different areas. The second one has to do with the symptoms that you put in your symptomology solution questionnaire. The third one shows the significance of labs and the numbers in the labs. And it's broken down into different areas where the genes, all the different genes that could affect how we're using or oxidizing our iron, or NOS uncoupling, or how we make and use glutathione. They're all lumped together. Another thing to think about is think of this as a river. Here's the snow cap, all the way down to where it dumps into the ocean. If there are different problems, you could think of a river with a dam here, another, a dam here, another dam here, and another dam here. People all the way at the top could be flooded and underwater, but they may not have a problem. The problem is because things can't flow downstream and out. So we always start down at the bottom and clean up the mess and work our way up. And if you look, up here is MTHFR and folic acid and methylation. These are some of the last things we address. A lot of times, if this is addressed first, a lot of people start taking much higher doses of methylfolate or methyl B12, and they feel better at first because they need it, but that just pushes the problem further downstream, and if there are blocks down here, they usually feel terrible a couple of weeks later or a month later. So we need to proceed in an orderly way from bottom to top. So what we're doing when we're looking from some of the labs and the different genetic reports, we want to make sure that the good guys, there are plenty of them, and the bad guys we help reduce. The good guys are nutrient-filled foods. Superoxide dismutase, SOD, that helps decrease inflammation. Catalase, glutathione, SAMe, NADH. We'll talk about nitric oxide. I mentioned BH4 is needed to help make our neurotransmitters. Folate, NRF2, choline, and balanced neurotransmitters. Some of the bad guys are excess glutamate. That can lead to sleep problems and to severe anxiety. Ammonia buildup can lead to the same thing. Our sulfates and sulfites need to be balanced. If we need to make sure we don't have too much superoxide, that can cause massive inflammation throughout the whole body. We'll talk a little bit about NOS uncoupling. We want to minimize that, and peroxynitrate, hydroxyl radicals, homocysteine, histamine, and zonulin. If any of these on the right side are in excess, that can cause major problems in the body. This is what a genetic report looks like. It gives you where it is on the gene, the position, and the genotype, but it's really not that helpful. You really need to get it put into a good program that can then put this into English. What do these different genes do? What enzymes do they affect? So our DNA controls everything. How you make nutrients, neurotransmitters, hormones, energy, how you activate your vitamins, how you clear toxic substances, how you make and use antioxidants. Nutritional DNA testing and analysis can help determine what support you need, how to compensate for nutritional deficiencies, and how to clear toxic buildup. So what is a SNP? It's a single nucleotide polymorphism. And SNPs can occur in the coding regions, the non-coding regions, and in between genes. So how useful is this information? Well, if we look at the genetic patterns along with labs and symptoms, it might suggest a nutrient deficiency such as SOD, superoxide dismutase, folic acid, or folate, B12, trimethylglycine, we need that for methylation. And if there is a deficiency, we can suggest a good supplementation routine to get that back into the system. If genetic patterns along with labs and symptoms suggest higher levels of some of the toxic substances like ammonia, peroxynitrite, homocysteine, we suggest the use of a scavenger product along with nutritional support to help the body clean up this metabolic mess and eliminate these toxic substances. With a SNP, an enzyme may decrease in function, causing a toxic metabolite to be formed. It can cause changes in hormones, neurotransmitter function, and functions of the mitochondria. The mitochondria are in every single cell. That's where everything goes on, where we generate energy all the way down to detoxing and hormone production. So making sure the mitochondria and all the pathways that occur there are functioning properly is essential. So we have thousands of reactions occurring per second to make our mind and body work. DNA is the instructions on how to make the enzymes that turn substance A into substance B. SNPs in the DNA that we inherit or lack of cofactors can impede these reactions, resulting in metabolic dysfunction. So finding the SNPs, the results of the SNPs, can allow you to create a plan to compensate for inherited deficiencies. Alright, so now we're going to start talking about a couple of very interesting products and the pathways they work on that we're having excellent results with. The first thing I'm going to talk about is nitric oxide and nitric oxide synthase. That's the NOS enzyme. Nitric oxide is an important signaling molecule and a cytokine. Nitric oxide was thought to be relatively insignificant until the 1980s and 90s. In 1992, the American Association for the Advancement of Science proclaimed that nitric oxide was the molecule of the year, and in 1998, a Nobel Prize was awarded for the discovery that nitric oxide is a key molecule in the cardiovascular system and helps keep the blood vessels healthy and blood pressure regulated. Since then, nitric oxide has been found to also be essential in many other systems, including the immune system, the nervous system, the brain, and many chronic conditions and diseases such as chronic inflammation, erectile dysfunction, and cancer. Nitric oxide synthase, NOS, is the enzyme responsible for the production of nitric oxide. Nitric oxide is a signaling molecule. This means that it's a group of atoms held together by an electric charge. It's produced naturally by the body, and it's important for many aspects of health. According to Dr. Nathan Bryan, he's author of several studies on nitric oxide restoration and the book Nitrates and Nitrites in Human Health and Disease. In response to the argument that nitric oxide is involved in a pathology, he uses the example that police are at every crime scene. It doesn't mean they cause the crime. They're there to control the environment. This is the same with nitric oxide. It appears in both acute and chronic issues. It doesn't mean that it's part of the problem. It's part of the anti-inflammatory response system, the immune system. It's there in a protective role. It's not causing the pathology or the condition. Nitric oxide's most important function is vasodilation, meaning it relaxes the inner muscles of the blood vessels, causing them to widen and increase circulation. Its production is essential for overall health because it allows blood, nutrients, and oxygen to travel to every part of your body effectively and efficiently. A diminished capacity to produce nitric oxide is associated with heart disease, diabetes, and erectile dysfunction. Nitric oxide's most important function is vasodilation, meaning it relaxes the inner muscles of the blood vessels, causing them to widen and increase circulation. Its production is essential for overall health because it allows blood, nutrients, and oxygen to travel to every part of your body effectively and efficiently. A diminished capacity to produce nitric oxide is associated with heart disease, diabetes, erectile dysfunction, and many other conditions. This is a look at nitric oxide synthesis. Arginine is combined with a molecule of oxygen, and it uses the endothelial nitric oxide synthase enzyme to do this, and it uses tetrahydrobiopterine, BH4. And that's converted to BH2 in the process, and oxygen is put on from there to make nitric oxide. You get the nitrogen from arginine, and the oxygen is from oxygen, of course, to make it, and the final product is citrulline. And when this is working fine, BH4 gets converted to BH2. It needs the DHFR enzyme, and that keeps the NOS enzyme coupled. Everything sort of links together. NADPH is used, and the end products are citrulline and nitric oxide. But things can go wrong. we need enough BH4, and that requires BH2 to be recycled back to BH4. Not having enough NOS enzyme, then L-arginine turns into superoxide and peroxynitrite. Those are very, very strong and damaging free radicals that cause inflammation. Glutathione is needed to neutralize peroxynitrite. So if it's being used up, let's say by a heavy metal or a toxic exposure, the metals and all of our metabolic waste is building up in the body because there isn't enough glutathione to help the body detox. A lead exposure impairs the NOS enzyme. Aluminum impairs the conversion of BH2 to BH4. BH4 can also be depleted by such factors as high ammonia levels, which pulls BH4 to detoxify it. We also need cofactors such as NADH. So there are multiple things that can go wrong to make nitric oxide. BH4 is a very important cofactor for the conversion of phenylalanine to tyrosine by phenylalanine hydroxylase, and then by tyrosine hydroxylase putting another hydroxyl group on tyrosine to make dopa. It is also used to take tryptophan to make serotonin, and it's needed to convert arginine to nitric oxide. Serotonin, tyrosine, and L-dopa are all neurotransmitters. And nitric oxide we know is needed for vasodilation. So just looking at this chart, if there isn't good conversion from BH4 back to BH2 and we don't have enough BH4, it can affect our neurotransmitters, our nitric oxide, the amount of ammonia, the amount of free radicals that are being generated. So everything needs to be in balance. And again, that's why just treating one SNP usually doesn't work. High blood pressure is a major risk factor for cardiovascular disease, and reduction of elevated blood pressure significantly reduces the risk of cardiovascular events. Evidence suggests that nitric oxide plays a major role in regulating blood pressure, and that impaired nitric oxide bioactivity is an important component of hypertension. Nitric oxide molecules resist plaque formation in the blood vessels. It helps restrict vasospasm and abnormal clotting. If you can make and maintain nitric oxide, then you reduce the risk of developing cardiovascular disease. Improving nitric oxide levels is a priority for anyone experiencing circulation and cardiovascular symptoms. When you look closely at people who are struggling the most with their health, many times nitric oxide synthase, NOS uncoupling, and low nitric oxide are involved. Nitric oxide can prevent high blood pressure and thereby protect the heart, the brain, and kidneys. It can keep your arteries young and flexible, prevent or slow or even reverse the buildup of clogging plaques in the arteries. It can help stop the formation of blood clots. It can lower cholesterol, reduce the risk of heart attack and stroke, reduce the risk of diabetes and complications such as kidney disease, blindness, hard-to-heal foot and leg ulcers, and amputations by increasing blood flow. It can limit swelling and pain of arthritis, boost the power of pain-relieving drugs, reverse erectile dysfunction, calm the choking inflammation of asthma, protect bones against osteoporosis, help provide mood-lifting power behind antidepressant medications, assist the immune system by killing bacteria, and limit skin damage from the sun. This is really quite an important molecule in our body. When there's low BH4 relative to NOS or BH2, oxygen activation is uncoupled from L-arginine oxidation, and NOS produces superoxide instead of nitric oxide. This superoxide reacts with nitric oxide to produce peroxynitrite. The molecular formula is ONOO, oh no, and it is an oh no. It's a highly reactive molecule that oxidizes BH4 and causes more NOS uncoupling. BH4 depletion and NOS uncoupling contribute to a number of vascular conditions, including overload-induced heart failure, hypertension, ischemic reperfusion injury, and atrial fib. The main thing to take away from here is that when everything works right, we get enough nitric oxide. When it becomes uncoupled, we have low nitric oxide, and that combines with superoxide to make peroxynitrite, and that's very dangerous for us. NOS uncoupling increases peroxynitrite, and this lowers ATP. ATP is made in the mitochondria, and that's our energy. We need ATP. That's how all the cells work. That's how we're awake and we have all this energy, how all the work and functions get done in the body. The lower the ATP production, the worse the glutamate to GABA conversion gets, and that causes more anxiety. NOS uncoupling is a huge problem, and one of the first things to look for. If you can support this so it doesn't interfere with the healing process, you'll get better that much faster. Studies have linked superoxide and peroxynitrite to Alzheimer's, arthritis, autism, bipolar, depression, fibro, Lyme, infertility, migraines, that goes on and on, Raynaud's, the cold hands and feet, ulcerative colitis, idiopathic pulmonary fibrosis, to name a few. By the time we're 40 years old, our ability to produce nitric oxide is only at 50%. By the time we're 60, it's down to 15%. So we have to have another way to support nitric oxide production to keep our circulation and microcirculation healthy. Nitric oxide is important to every organ of the body. Women have a slightly higher level because estrogen prior to age 60 is higher, and that helps protect the nitric oxide. Any medication that can raise blood pressure is affecting eNOS, one of the nitric oxide enzymes. Some of the examples are the PPIs, the protein pump inhibitors, and birth control pills. Antibiotics also influence the microbiome, not only in the gut, but in the mouth, which is important. So the gut bacteria at the back of the tongue take the nitrates in our food, and the bacteria that's there converts it to nitrite. And then when it hits the acid in the stomach, it gets converted into nitric oxide. So using mouthwash, antibacterial mouthwash, and whitening toothpaste that have hydrogen peroxide, that kills a lot of the bacteria in the mouth, and that can lead to a decrease in nitric oxide. SNPs that influence BH4, causing NOS uncoupling, also influence our nitric oxide formation. The NOS enzyme goes from an enzyme that creates nitric oxide to an enzyme that creates superoxide. If anyone has the MTHFR SNP, they're probably low in BH4, which also causes low nitric oxide formation and NOS uncoupling. One clear indicator of nitric oxide production, or low nitric oxide production, is Raynaud's and cold hands and feet. The thyroid has an OX enzyme called DUOX1 and DUOX2. It produces superoxide and hydrogen peroxide. The concentration of hydrogen peroxide has to be a specific amount for the TPO enzyme to function correctly. But the NOx enzyme gets stimulated by mold, high iron, oxalates, histamine, glutamate, smoking, stress, aldosterone, EMF, dopamine, sulfites, and homocysteine. We have an environment that we're living in that stimulates the NOx enzyme to make superoxide and reactive oxygen species. These are very damaging. So the nitrate to nitrite to nitric oxide pathway will stimulate nitric oxide formation, which inhibits the NOx enzymes, which is very helpful. People have had improvement of thyroid problems when they take nitrate supplementation. So if this is an issue for you and you have a thyroid issue, it might be easier to help balance your thyroid if you start supporting nitric oxide. So what are some of the lifestyle changes we can do to help with nitric oxide formation? Eat vegetables high in nitrates. Vegetables like celery, lettuce, beetroot, spinach, and arugula. In fact, eating nitrate-rich vegetables can lower blood pressure as much as some blood pressure meds. Increase your intake of antioxidants. Nitric oxide is an unstable molecule that degrades quickly in the bloodstream, so it must constantly be replenished. Nitric oxide stability can be supported by consuming antioxidants. You can use nitric oxide boosting supplements, and we'll talk about that in a minute. Limit the amount of mouthwash. Mouthwash, as I said, destroys all types of bacteria, and the beneficial bacteria in the saliva are important to nitric oxide production. You want to avoid antacids. Every time we swallow our saliva, we generate nitric oxide, providing there's enough stomach acid. And expose yourself to a little ultraviolet light and infrared light. Ultraviolet light liberates nitric oxide. This is beneficial as long as nitric oxide is not deficient. Infrared releases nitric oxide bound to metals, but again, if nitric oxide is deficient, you'll have no nitric oxide to release. You can increase available nitric oxide by giving beets or beetroot powder before light exposure. Here's a couple of helpful hints. Nasal nitric oxide is produced in high quantities in the upper airways. It's thought to be involved in host defense functions, preventing bacteria and viruses from getting in the body, and regulation of mucociliary function. The measurement of nitric oxide, nasal nitric oxide, is easy and non-invasive. It has evolved into a screening test to exclude primary ciliary dyskinesia in those people with symptoms because nasal nitric oxide is extremely low in this condition. So some things you can do: if you inhale through your nose and exhale through your mouth, that increases nitric oxide. Also, humming does too. In a study comparing nasal nitric oxide production by humming compared to quiet breathing, nitric oxide increased significantly during humming and stayed elevated for 15 minutes. When inhaled, nitric oxide dilates the arteries in the alveoli, maximizing the penetration of oxygen into the bloodstream. Nitric oxide levels in exhaled breath are a non-invasive marker that can be used to diagnose various respiratory diseases and monitor a patient's response to given therapies. A portable and inexpensive device that can enable selective nitric oxide concentration measurements in the exhaled breath samples is needed to do this, and it is available. So some dietary recommendation. Beets are rich in dietary nitrates, which your body can convert to nitric oxide. According to one study in 38 adults, consuming beetroot juice increased nitric oxide levels by 21% after 45 minutes. Garlic can boost nitric oxide levels by activating the NOS enzyme. Organ meats, fatty fish, and muscle meats like beef, chicken, and pork contain the highest concentrations of CoQ10, which is believed to preserve nitric oxide in the body. Good dark chocolate. Research shows that the flavonoids found in the dark chocolate can help establish optimum levels of nitric oxide in your body. Leafy green vegetables like spinach, arugula, kale, cabbage are packed with nitrates, which convert to nitric oxide in the body. Citrus fruits like orange, lemons, limes, and grapefruit are good sources of vitamin C, which can enhance levels of nitric oxide by increasing its bioavailability. Nuts and seeds are high in arginine, which is needed in the production of nitric oxide. Watermelon, believe it or not, is one of the best sources of citrulline, an amino acid that's converted to arginine and ultimately to nitric oxide. Beetroot contains high levels of dietary nitrates, and intake has proven effective at increasing blood nitric oxide concentration. Through a chain reaction, the body changes nitrates into nitric oxide, which helps improve blood flow and pressure. Beetroot supplementation causes nitrates to be higher in the body. It's reduced by the bacteria in the mouth to nitrites, which is reduced by acid in the stomach to nitric oxide, which is bioactive in the tissues in the blood. NOS complex is a new natural creation product with beetroot, grapeseed extract, olive leaf, malic acid, theobromine, and hawthorn. Grapeseed extract supports nitric oxide synthase in the endothelial cells. It's the same enzyme that Viagra acts on. This means grapeseed extract will increase nitric oxide levels just like pycnogenol, which is a patented extract of the French maritime pine bark. It has protective effects against cardiovascular events and atherosclerosis by upregulation of the NOS enzyme. And that leads to increased nitric oxide being formed. Olive leaf extracts and their constituents are well known for their blood pressure lowering effects, and recent studies have revealed even more benefits, including anti-inflammatory, antioxidant, lower blood sugar, cancer protection, cholesterol reduction, neurodegenerative diseases, help with prevention of that, and even help with arthritis. Malic acid is believed to help lower blood pressure by adjusting levels of L-arginine and nitric oxide. It's a precursor to the formation of ATP. We talked about that. That's the energy that fuels cells and allows them to function properly. It's present in apples, wine, and many other fruits and vegetables. Theobromine from dark chocolate has been shown to significantly lower blood pressure. It increases the activity of a messenger called cyclic AMP. This messenger activates an enzyme called pKa, which reduces inflammation and causes widening of blood vessels and increases stimulation. Theobromine also blocks the adenosine receptor, which usually trigger hormones such as norepinephrine that increase blood pressure. There are more than 60 species of plants that contain theobromine, but is most concentrated in tea, chocolate, cola nuts, green tea beans, and cocoa beans, not coffee beans, cocoa beans. Hawthorn has been used to protect against heart disease and help control high blood pressure and high cholesterol. Studies show that it increases coronary artery blood flow, improves circulation, and lowers blood pressure. All right, now we're going to talk about NADH and that whole cycle. Many people have problems here. They either don't make enough NADPH, or it's being used up by toxins or the NOx enzyme, NADPH oxidase, when it's upregulated. The NADH and the NOx enzyme must function properly for good detoxification, energy production, mTOR and autophagy balance, DNA repair, mitochondrial health, sulfation, the urea cycle, to help slow down aging. It assists in our immune function, nitric oxide production, vascular health, antioxidant recycling, and glutamate clearing. So you can see how vital having good NADH production and utilization is. This shows the many roles of NADPH. NADPH is a cofactor in the normal pathway to make nitric oxide. It's the reducing agent for oxidized thiodoxin or triodoxin, which is needed to clear hydrogen peroxide. It's the reducing agent to take oxidized glutathione back to reduce glutathione. We should never really need to take glutathione when we're healthy. It should get recycled completely, 100% of it. So it just getting recycled and reused. But when we're low in NADPH, that doesn't happen. It's also a big part of the heme to ferritin pathway, so for our iron balance. It's part of the cytochrome P450 to take heme into carbon monoxide that goes down the path of the NRF2 enzyme. This is critical because the NADPH recycles glutathione, recycles the TRX, which is thioredoxin, and if this doesn't occur, we can have a reaction called the Fenton reaction going on, which causes high levels of very, very damaging free radicals. Hydrogen peroxide is one of them, and that combines with iron and makes the hydroxyl radical, which causes an awful lot of damage and inflammation in the body. Here we see the role of NADPH and NADP plus in the nitric oxide cycle. This is very, very important, and if you don't have enough NADPH, then you have NOS uncoupling, which we spoke about a little earlier in the presentation. This is the folate and BH4 cycle. Folate is converted to tetrahydrofolate, then to 5,10-methyl tetrahydrofolate, where there's crossroads that are partially determined by the NADPH ratio to NADP+. NADP+ works with the enzyme MTHFD. It's unbelievable. Everything is letters and acronyms, and it's a little hard to follow. And that directs the 5,10-MTHF to synthesize nucleotides. NADPH is needed for folate for methylation. If we don't have enough NADPH, we shift the redox balance towards oxidation, which is dangerous. It's very important to have adequate amounts of NADPH before we consider taking folate. This is why some people that have the MTHFR and take folate or methylfolate don't feel better. They get worse. So if we look, let me get my mouse back here. So if we look, we need NADPH to convert to NAD+. We need a good ratio there. That's how we go from folate all the way down to methylfolate. And here's the MTHFR enzyme. If we don't have enough NADPH, it doesn't matter what's going on with MTHFR. And if we start throwing in more folate or methylfolate, that can back things up even further, causing many, many problems. So the primary functions of NADPH, it contributes to antioxidant systems functioning. It's used during reactions of NADPH oxidase, that's the NOx enzyme, to make reactive oxygen species, which in the right amount are very healthy for us. It acts as a reducing agent in the reactions by donating electrons to be used in reactions which include the formation of DNA, our fatty acids, and our steroids. The lack of NADPH can cause hemolysis, or the rupture of red blood cells. Without NADPH, membrane damage, cell membrane damage occurs. When you supplement with NADH, cerebral electrical activity increases, as does your attention, cognitive function, focus, memory, concentration, and decision making. NADH increases the production of ATP. NADH carries the electrons needed for the synthesis of ATP, and this directly corresponds to the benefit towards brain function. And remember, ATP is the power supplying each brain cell. NADH is also needed to prevent brain tissue damage with aging, even decreasing the damage done by strokes. NADH increases neurotransmitter levels, so we don't need large amounts of it. For most people, 10 milligrams once a day. Some people go up to 20. We just need some to keep the balance right. Research has shown that proper amounts of NADH will boost energy levels and stamina, reduce fatigue, reduce the possibility of age-related diseases. It can help with lowering blood pressure, provide protection and energy to your brain, and boost cerebral blood flow. While several NADH-dependent conditions, such as thyroid levels, metabolism, immune response, inflammation, weight gain, metabolic syndrome, high blood pressure, obesity, diabetes, cholesterol, cardiovascular disease, and stroke, have been associated with NADH levels or low levels. Chronic fatigue is also directly related to NADH by the body's inability to produce energy, ATP. Without energy, the cells simply cannot function properly. Chronic fatigue compounds the conditions already mentioned above, or a little before. Low NADH worsens weight gain by not being the energy source the body needs. Without energy, processes like metabolism start to slow down. Low NADH compounds the problem by promoting weight gain through secondary sources like diabetes and heart failure. Heat exposure, natural as well as artificial heat exposure such as saunas and hot tubs, has been linked to an increase in NADH. Scientists find this interesting since many people who suffer from extreme joint and muscle pain, like those with fibromyalgia, experience an increase in fatigue when they're exposed to colder temperatures. When exposed to an increase in heat for a significant period of time, perhaps sitting in a sauna, the body's heart rate begins to pump harder because the body requires energy to sustain the cool down. This mini workout of sorts forces the body into additional production of NAD+ to cover the extra energy production. Limiting direct sun exposure is important. While heat can be a key factor to increase NAD+, too much direct sunlight can deplete NAD+ levels in the body because the body uses NAD+ to repair cells that are damaged because of the ultraviolet rays. So everything is really a balance. And the last product I'm going to talk about is H2 Infuse. There was a lot of studies done about hydrogen water and drinking hydrogen water and how protective it is for the body. The hydrogen getting into the body can help decrease hydrogen peroxide levels, which we talked about earlier, and the hydroxyl radical and peroxynitrite. So it can decrease some very damaging free radicals, which is beneficial for all of us. We're all exposed to toxins, and most of us genetically and metabolically, our systems aren't working at 100%, so we do need some support. The problem was you needed to buy a hydrogen generator, which could cost thousands of dollars, so it wasn't practical. Now there are products like this one, H2 Infuse, which is wonderful. You take a tablet and drop it into about 8 ounces of water. It takes about a minute and a half for it to bubble and fizz, and it saturates the water with hydrogen molecules, and you drink it right down within a minute or two of when it's dissolved. And this protects you from free radical damage from exercise, environmental stress, metabolic conditions, genetic conditions, and toxicity. And I found that a lot of people, when they start taking this, they find that their stiffness and inflammation start going down right away. So that's the lecture that we were going to give in March at the store. So you have the information now. And the products that I talked about were the H2 Infuse, NADH 10 or 20 milligram, and NOS Complex for nitric oxide building. The NOS Complex, you take 2 capsules twice a day, morning and evening. The H2 Infuse, you put in water, and it's once a day. Some people do it twice a day. And NADH, the 10 milligram, it can be once a day. If you have any questions on these products, we usually take questions and answers at the end of our seminars. Please feel free to contact me at 781-893-3870, extension 111. You can leave a message and I'll get back to you if I don't answer the phone. Or you can email me your questions at gary@naturalcompounder.com. Thank you very much.